there is a glitch with their website this week. I'm trying to get that resolved, but it is not yet resolved. So give me a day or two to get that fixed. And anyway, let me go ahead and turn it over to Brian. Brian, if you want to just tell us a little bit about yourself, and the floor is yours, good sir.
Okay, Jason, thank you very much. So yes, I am the product manager for air barriers and wall insulation for commercial construction with Carlisle Coatings and Waterproofing, and now also with Henry Company, since my employer has acquired Henry, for those of you that don't know that. So handling a big slice of the air barrier market now. I mentioned earlier that I've been in this position for 17 years, have seen a lot of installations, have overseen the launch of a lot of good products, some not so good, but those aren't on the market, only good ones, right? And then I'm going to talk through, I recognize from Jason about the IECC changes, which I'm going to talk about in this next slide here. And then right after that, I'm going to talk about a case study we did down in San Antonio, where the client insisted on whole building air leakage and how we dealt with that situation. So Jason, if you want to talk through the code changes, I mean, this is what I distilled out of it. There's a lot of ambiguity and openness for interpretation of that language, but Jason, if you can give some insight into that.
Yeah, and this is on my to-do list to send to ICC for an interpretation, because frankly, this code section, I've read it 7 times now, and I have probably at least 4 different meanings each time I read it. And it's just, I mean, ultimately during the code development process, you're going to have some poorly written sections. And in particular, this one starts at C402.5, which air leakage thermal envelopes, the title, right? And what's crazy is it tells you that the building thermal envelope shall comply with 402.5.1 through 402.5.11. So this whole section, it shall comply with, or it shall comply with the middle part of this section, which is the air barrier testing section. So it tells you it shall comply with the whole section, or it shall just comply with the middle section, which is basically what your client wanted, which is tested. But really, it shouldn't have said comply with the whole section when the testing is part of the section. And then what is exempt, so 2B is exempt on groups other than, so, and there's 2 different testing, and it shows it here on Brian's slide. You're testing at 0.3 CFM a square foot for group R and I. You can have a little looser building for non-group R and I, which is 0.4 CFM. And then greater than 5,000 square feet in climate zone 2A. So Houston, you know, everywhere, San Antonio, Austin. So greater than 5,000 square feet will be exempt in 2A. 2B is exempt across the board for other than R and I. Well, even group R and I, 2B is exempt. And then in climate zone 3A, so our Dallas, Fort Worth, that whole area, between 5,000 and 50,000 square feet is exempt, which I can't quite understand why you would need to blower door test a building that's 51,000 square feet, but not between 5 and 50. And then so it tells you to test it. And then it says, well, if you don't test it, you can use one of 16 materials or one of 3 assemblies, which is real similar to what's in the 12, 15, and 18 IECC, right? Just that prescriptive list of things you can use for an air barrier. But it gets a little more detailed, and it'll tell you, well, if you don't test it, you can use from this list of materials, from this list of assemblies, but, and then there's some additional, you also have a verification component, which basically says, hey, you had to have looked at it at plan review, you had to have inspected it, and you have to have a commissioning report on the air barrier. Additionally, some other things that just make it more confusing. So, you know, when they list that air barrier, you know, what does it have to be? Well, it says either tested or comply with, and the things that it lists, you know, it has to be continuous. The seams and transitions and penetrations, et cetera, have to be sealed. It talks about fenestration air leakage, rooms containing fuel burning appliances, doors to shafts, elevators. Well, all of that would still evidently that stuff goes out of the way because it tells you, well, if you test it, you can test it, and then only the air intake exhaust, loading dock seals, vestibules. And so to make a long story short, by the next time I give my 2021 IECC commercial presentation, I will have all of this worked out because there are about 4 to 5 different interpretations that I'm going to have to send off to ICC for, because it's frankly just clear as mud. But really, I think the long story short is we are going to be testing some buildings commercially in Texas now. It is going to be required depending on size and climate zone. And then number 2, even those that we don't test, we are going to have more stringent requirements as far as we need to make sure we've plan reviewed it, inspected it, and have a commissioning report on the air barrier. Apologize for running so long there. The floor is back to you, Brian.
Oh, thank you for that, Jason. So let's get into the meat of the presentation here. And this is a case study on how an office building was built 4 times tighter than the code requirement, that being the 2018 version of IECC. So this is right here in the state of Texas. It's the Broadway office development complex in San Antonio. You can see it was constructed pretty recently. The owner was Silver Ventures. So it's a 254,000 square foot building, 8-story office building with a 6-story mixed use retail. The general contractor was Joris and Kirksey Architects. So a project I would definitely like to go see now that it's completed. When I get down to San Antonio. It looks very nice. So a little bit of history behind that. The owner and the tenant were the ones who drove the need for the whole building air leakage performance. So it was not explicitly a code requirement. This was a client-based private initiative, if you will. They took great pride that this project would be a LEED platinum building, and the very tight measurement of the whole building is part of that. The owner and the tenant, now this is the voice of the installer of all the systems that I'm going to be going through. They told me they were part of these job site meetings, and they voiced this need early, often, and adamantly. They really wanted this to happen. They did have a requirement for return on investment of less than 14 years. And they wanted the building to be 2 times more thermally efficient and 4 times tighter than code. I believe they got that air tightness from the Corps of Engineers specification. That's 0.1 instead of 0.4. And of course, there were other requirements that went beyond that, the open and flexible space for the client, and just functional features of the building that go beyond the scope of this presentation. So I'm going to go through what was planned. So the whole building air tightness, first we had to plan how that would be done, then execute it, and then prove that it was done. So in the planning stage, what happened, they added another section to the Division 7 specs called pressure testing and air system for air tightness. So mind you, all the other more conventional sections were already written. You had the general contract and the sub-trades who had already submitted their bid. Now they added this in here to kind of try to bring it all together and have some air tightness. The test method established, it was one of those accepted by the code, the E779, for whole building air leakage testing. And again, just to reiterate the performance requirement, 4 times tighter than code, as you see from this number. In that section were test agent qualifications, what, when, and how to test it. There was also called for some IR thermography to look at the thermal efficiency and to locate any air leaks, especially important if the building would fail that test, and a diagnostics protocol for a failed test. So the installer that we worked with, Alpha Insulation Waterproofing, they were savvy enough to know that they did not want this building to fail the test after it was fully constructed. It's very difficult and expensive to make repairs after the fact. So the strategy was to really get on this during construction and make sure that this building wouldn't fail this test. So again, I mentioned the specs. That section was added in the specs later, and the related sections don't reference that or support that whole building spec. But the the subcontractors whose work would affect that performance, they were tasked to meet it, but fortunately they were allowed to bid the extra material and labor and the means and methods that they thought would be necessary to meet that requirement. So for meeting that air leakage, you're talking about a lot of different things that are affecting it, not just the air barrier materials such as what my employer sells, but anything that is joining to it or penetrating it. Specifically, you've got fenestration, you've got cladding attachment, you've got junction to other wall assemblies, junction to the roof. So you got to, someone has to really own this and bring it together. And the installer, Alpha Insulation and Waterproofing, since they were putting in the below grade waterproofing, they would put on the wall air barrier and the deck waterproofing, and they're also doing all the caulking for the windows and a lot of the building flashings. They volunteered to guarantee a tight building with their work. And they adjusted their scope of work accordingly. Now, to do that, Alpha, who we've done business with for a long time, the material manufacturer, which is my employer, we partnered with the installer and we agreed to provide one site visit per week and a report. So again, this is just to make sure that as we build this thing, that everything is tight and we don't see any reason why it should fail that whole building test once we get there. So just looking at the other Division 7 specs and the materials that were used. This was the air barrier spec, nicknamed AVB, and this was a fluid applied permeable system. There were multiple manufacturers in the spec. Carlisle Coatings and Waterproofing was one of them. So with Alpha, partnering with us to do all those visits and reports, they're going to use the Carlisle materials everywhere that they can to make it worth our while to come there and perform these inspections. The material that was going to be the main air barrier in the opaque walls it's a waterborne acrylic, and it cures out to 40 mils dry, so it's a pretty high build coating. Compare that to latex paint, which is maybe 4 mils, so it's 10 times thicker. It's like putting on 10 coats of paint. Yeah, like I said, there were other products in the spec. This is pretty conventional technology, 6 of them actually, and it was the waterproofer Alpha who made the product selection. So as I mentioned earlier, with the obligation for the manufacturer to come once a week and walk the job site with the installer, they also gave the work to the same manufacturer for the cold applied waterproofing, which is a moisture cure silane terminated polyether that was put on the basically on anywhere that you got overburden, like concrete topping slab or pavers and pedestals, was this cold applied waterproofing. And there was a single ply roof. Actually, no, it was a modified bit roof on some of the job as well. Okay, so this is what they specified. It was a moisture cure, 120 mil reinforced, and any tie-ins to the air barrier or the air tightness through this system itself, also part of the scope of our work and inspections. And then you had some related sections where even if it wasn't the materials provided by Carlisle, it was materials that were either going over it or joining to it or sometimes going through it. So you can see here an array of materials. You got the exterior insulation, which is a thermal insulation. It was a 4-inch mineral wool with a clip and rail system. So all those rails had to be attached through that air barrier. And yes, we had to make sure that was air and water tight. And then once those rails are on there, then it doesn't really matter what happens outboard of that from an air and water tightness standpoint anyway. Joint sealants. So all that fenestration has got to be sealed to the air barrier in the opaque wall with, there were silicone joint sealants. So we needed adhesion, compatibility, details on how that seal would happen, and of course the sequencing of work to make sure you could do it. There was a portion of this project that had a lot of masonry veneer, but also a concrete block backup wall too. And it was masonry veneer also going to gypsum over steel stud sheathing. So there you had brick ties and through-all flashings, potential areas of air leakage going through the air barrier. The substrate condition was also important. So, you know, the air barrier installer has a knowledge of substrate requirements for the concrete masonry unit and the exterior gypsum. So we don't want the liquid applied product to go over unacceptable substrate. Got to make sure that that's in good condition, that you can cover it well with that air barrier. The mod bit roofing was done by a different trade, but we had to figure out the tie-in of that to the wall air barrier and also to that cold applied waterproofing. And there were a number of metal flashings that were also into the scope of work from Alpha Insulation and Waterproofing that tied the various systems together. Compatibility, also very important. Might not seem like that big of a deal when you look at one detail where it's just a little circle where the sealant is, but yeah, when you multiply that by hundreds of lineal feet of joint, or you know, hundreds of windows, and you use the wrong sealant, that's a bad day. So we made sure that anything that was touching our products that was a sealant or a chemical of some sort was compatible. And we have a standard list here, but we also will approve other materials if they're not on our list to see if they'll work, or recommend substitutes if something's unacceptable. Okay, so that was the planning end. Now we go to the installation. So I mentioned kind of in that last slide there about the sequencing for the windows. I mean, that's important for anytime that you have your air barrier membrane, it's going to be buried in the assembly, inaccessible once the work is finished. So any tie-ins, ideally they happen at that, where that blue stuff is, that is the fluid applied membrane. You're tying into that. You're not caulking at the face brick, for example, trying to do your air barrier. Everything's got to join physically at the air barrier level. And in that planning stage, you have the shop drawings where you do what's called a pencil test, where you identify the layer that's your air barrier, and you go from, let's say, from the wall to the window, and you should not pick up your pencil as you trace over what is the primary air barrier from one component to another. So make sure everything is joined continuously. So you can
yeah, sorry to interrupt, Brian, but for the inspectors in the field, that what Brian just said is crucial. It's that continuous air barrier component. So if you get out there and you see them, you know, on the picture Brian shows there, if you see them hopping from one plane to another, but they don't have sealants on those dissimilar materials that will allow for expansion and contraction, then that's no longer a continuous air barrier. I love how you talked about it being all on one plane, the pencil test. Anyway, that well described, and apologize for the interruption. Continue.
So look at this photograph here where they got the brick veneer going up over the air barrier. So you can see some of it is still bare gypsum sheathing. They haven't put the air barrier on there yet. A lot of times there's pressure for the brick, for the masonry trade to, you know, they get paid by how fast they could lay bricks. And you don't want them to get ahead of the air barrier work that's already done and also inspected, right? A lot of times they'll cover the work before it gets inspected. Now you got bricks in the way. The other challenge is looking at those window openings. The way to seal that window direct to that membrane was much easier to do if that was done with the windows on before the brick veneer. But you know that for practical reasons, they don't want to do that because, you know, if you got the windows in there already, the mason trade, I mean, they got wet mortar and guys handling bricks. They're afraid of getting mortar on the windows or breaking them. So they're wanting to get the bricks up first. But I'll show you later in the presentation, this posed a considerable difficulty. Now, you know, the caulking trade has got to figure out how the heck do I seal this window to the air barrier now if this brick is up and in the way. So sequence of construction is very important. You know, I mentioned that pencil test with the details, but you've also got to figure out, okay, now what's going to be required for me to actually build that? I mean, drawing it is the easy part. So here's more pictures of the installation. All the openings were back wrapped either with an embedded reinforced liquid flashing or with a peel and stick. And so the fenestration is going to be, there's going to be a silicone perimeter sealant that's going to seal the frame of that unit to the air barrier that's back wrapped into the rough opening. So that's where the seal is going to occur. And this just shows, this was a particularly workmanship intensive detail here where they managed to flash this arch. You can also see the joints between the boards. They had to be caulked and the screw heads patched with a compatible sealant. And also they've got the corners of the gypsum, right, where you got the raw edge and some cracks sticking out there. They have an embedded reinforcement and the liquid product coating all of that. So everything there is really nice and buttoned up and airtight, just the way you see it. And then you put that monolithic 40 mil cured coating, and that makes sure that all that's going to kind of perform as one piece and last once you get the brick up in front of that. So once they did all the detailing, and the detailing, by the way, is about 80% of the labor. You know, coating it on with the spray especially is fast and easy compared to detailing all that stuff. And I know that there are manufacturers that push thinner mill products to save money there, where they're putting on only 6 mils of membrane, or there are boards and tape systems. So those still don't omit all that labor that's required with guys all over the building sealing up all those joints and irregularities. So you know, the membrane is really kind of extra to add durability and continuity. You're coating the whole building with this thick layer of rubber-like material to really close up all those edges of caulking and tape and whatever. So this is the product here. You can see how thick it is, that roller dipped in the pail. There's a comb gauge for measuring thickness. And there's a guy spraying it on the wall there at very high thickness, 60 mils wet to get your 40 dry. Now we're going to cover some tie-ins. So here was a tie-in at the parapet, the roof cap here, parapet wall cap, I should say. So you have a peel and stick membrane going over the top of it, and then it's lapping into the onto the wall side where the liquid is, and then there's a tie-in of the roofing materials. You got to make sure to do that tie-in. It's done under a cover board, or it's done underneath the coping cap, so that because this material that's at the coping cap here that you see, this blue stuff, you can't put this directly under a black membrane. So you got to be mindful of the temperature restrictions. Anyway, since Carlisle is also a roofing company, we publish details how to tie wall stuff into roof stuff the right way. Here's more tie-in details and terminations. So you had these beams. They're up at the top of the building here. There's an I-beam penetration going through the top of that parapet wall. A column, the termination onto concrete. So the concrete is considered airtight. It's an air barrier, but how do you terminate that above grade wall onto that concrete? That's shown in the middle there with the column detail. And any electrical boxes got to be sealed around in similar penetrations. More details. So you had, again, the termination at the, that's going to have the cold applied waterproofing on it, that middle slide. So you got a peel and stick flashing terminating the base of the wall onto the plaza deck area. And then you have, that's the clip and rail system that I was talking about for suspending the cladding. And then the mineral wool insulation is going to get tucked around all those red clips. That's the left photo there. And you see they got some clips. It's best to put those clips on when the membrane's on already, but if you don't do that, you can coat and caulk around them also. But either way, you got to figure it out and make sure that that connection where that those red clips are penetrating the membrane are going to be airtight and watertight. And the photo on the right is showing a termination at the beneath the roof deck. So there's just we say a 3-inch bearing onto dissimilar substrates. You'll do that with a peel and stick flashing or with an embedded reinforcement. Okay, progressing through the work. Now here's the overburden. So I mentioned before, I mean, that this is your primary air barrier, and once it gets built into the wall assembly and covered up, it's going to be really hard to do anything about it if you don't like the results. So inspecting everything visually for continuity and for compliance with the details, very important. So you can see there's a, it's a guy, he's test fitting a piece of rigid polyiso foam board that was on part of the project. Most of it had the mineral wool semi-rigid bats, as shown in the photograph on the right. And you can't see it because the bricks are up already, but it goes between those silver rails.
What material? So mineral. If I'm thinking mineral. Go back a slide if you don't mind. When that brick gets saturated on those columns and you've got mineral wool underneath that?
Yep. Here's I'm going to this slide because you can actually see what that mineral wool material.
Okay.
So hey, not our choice, not our recommendation, right? That's a different manufacturer, the mineral wool. It's become very popular because of compliance with the fire requirements with NFPA 285.
Oh,
mineral wool is a non-combustible insulation. So it's not because of thermal or moisture performance, it's because of fire.
Man, I don't like that. I mean, that's because it's just gonna, what keeps it from getting wet and staying wet?
So it's supposed to drain, is what they say. They say it's water repellent, which it is to an extent, but it can get saturated. And it's kind of like if you picture your maybe your outdoor patio furniture where you got those cushions, and as long as the water drains out of it, it'll dry out. But if it traps the water like at a horizontal, like a relieving angle or a window header, you know, it's going to be wet for a pretty long time there. Yeah. So that's important also. I mean, with the details of making sure that the mineral wool is installed according to that manufacturer's instructions for it being able to drain and dry. Okay. All right. Keep on moving through the presentation. So it's just more photographs of, you know, the big challenge, which is providing the continuity before everything gets covered up. So you could see here, this is the window condition. And this is the situation where they can, so it's that where that rail is, right where that yellow arrow is pointing, that's where they want to put the silicone caulk. Okay, and so with the masonry and the way they needed a long nozzle and I had to have kind of a curve on it to get it into that gap where it needed to go if the masonry was in place already. So sealing that window to the wall is to the membrane on the wall is very important. And you could see there they got some of the those wing nuts. Those are posi tie anchors for holding up insulation, and they got a couple of holes on them where the wire ties go for holding up the brick. So this portion of the wall was masonry, and those wing nut ties are combination brick ties and insulation anchors. All right, so yeah, with that window, that was probably the most bothersome part of this installation. The alpha installation, they were telling me about how they had to develop a special tool to actually seal these windows to the membrane. And it was a blind application, even with that tool. So they water tested a lot of windows, and it was hit or miss whether they were able to seal them properly. So I'm getting to the testing part, of which I'm leading into. There were a number of tests done, not just the whole building test, to prove that this installation was tight. So the water leakage test, this is the ASTM E1105, and the acceptance criteria in this job were they wanted no leaks after 15 minutes at 12 PSF. So 12 PSF is a hurricane force wind. I think it's around 90 or 100 miles an hour. And they planned on testing 96 of the 458 windows. So just because of what I described there with the challenges in sealing the windows, a lot of them failed. So an additional 144 windows were tested, and they had to be caulked again to pass the test. It was a considerable expense. In the end, 240 out of the 458 windows were tested, but at the end of that, it felt pretty darn good about how tight the seal of the window to the wall is. Now looking at all those penetrations, they did this test called ASTM E1186, which is affectionately nicknamed the bubblegum test. So you can see what that device looks like. It's a little vacuum cleaner, essentially, that pulls a vacuum in that plexiglass salad bowl there that's configured with a weather stripping. You press that bowl up against the wall, you paint the specimen area with a, so it's a lot like kids' bubble soap. They call it surfactant. So costs a lot more than the bubble soap, but it seems to do the same thing. It's so you paint the one with the soap, and when you pull the vacuum, any leaks through the system show up as bubbles, which is why they call it bubble gum. So they did about 40,000 tests on this job, every brick tie, and their requirement is zero bubbling. If anything bubbled, it was going to get more material and more caulk until it didn't bubble. So the testing and reporting of this one was the general contractor who insisted on doing this. Now the site visits. So remember back in the first slide, I was talking about the manufacturer agreed to walk the site once a week with the installer and note any deficiencies. And this had to be done before the work could be covered up. So this is just an example of photographs from the site visit report where they would note areas that needed to be addressed. And the important thing, I got the caps down the bottom. I mentioned that earlier. You can't cover the work until it's inspected, because at that point it's very hard to do anything about it. Now, doing all that stuff in the building, we felt like with all that inspection protocol that it's very tight. Every possible air leakage path that we could identify looks to be addressed and sealed up pretty good. So now, in that Division 7 spec for the air leakage, we got they contracted a qualified independent testing agency that could do that whole building testing. These guys were TSI Energy Solutions, and they were made aware of the requirement. And so they configured the building for testing as shown in the bullets. They isolated floors 1 and 4 and the park deck. They basically excluded that from the test, since those were not part of the conditioned space. And then, well, the park deck was isolated. The lower floors were conditioned space. So they had 2 zones essentially. So they tested floors 1 through 4 as one zone, and floors 5 through 12 tested as another zone. And again, this was their expertise determining this. So it's important to get guys that know what they're doing. So they arrayed it with the blower doors as they needed to do to induce the steady pressure difference. In this case, it was a 75 pascals or 0.3 inches of water. And yeah, so you have to maintain that static pressure, and then you can measure the airflow that happens at the pressure. So these were their results. So they have to not just measure the flow, but they have to also measure the test area that's included in that test. So those 2 factors are going to determine crucially whether you pass or not, right? The leakage rate and the area. So according to their testing, you could see we passed. It was 0.088, so pretty darn close to that 0.1 limit, but under it. Very happy that we passed the test. So the conclusion of this, I hope I drove home the work on the front end before you get to the whole building testing is very important for having confidence, for even being able to pass it. And again, this was a standard that was set much tighter than the minimum requirements in code. So maybe it wouldn't need to be quite this rigorous, but this just shows an extreme example. And in this case, it worked well that we had one entity in charge of all the coatings and goopy sticky stuff that agreed to basically to have continuity of its work over the whole building and guarantee the airtightness of the building. Single source responsibility is the short way of saying that. And that is the end of the case study and the presentation. So I don't know if any questions, guys type any questions or what, but that's the presentation.
Well, first and foremost, I think since there were so many Carlisle products used in that building, you and Frank need to come down and see it, and y'all stop by the cantina and you can check it out in person. Most importantly, we'll get that out of the way. But I noticed during a lot of that presentation that, you know, you're having weekly inspections, and just with the 2021, imagine this same project wasn't going to be blower door tested. And again, I'm speaking to the inspectors and plan reviewers on the call now. And that's fine, depending on size and climate zone. There are some exceptions where perhaps it would not need to be tested. Actually, I guess in climate zone 2B would be exempt, but climate zone 3, it's over 50,000, so it would have had to be tested. But imagine it was in climate zone 2B. So those weekly inspection reports, that would be part of your commissioning report of that air barrier. So you would end up putting that in the building file. It seems, I just can't get over the designer of that building and it seems like a handful of ways, some continuous foam on the inside. I'm still surprised at what they decided to do with that. On the plan review side, I remember that one slide Brian showed that listed the products that were compatible based on the materials. And that's going to be a big one. I mean, steel expands and contracts at a significantly different rate than concrete, than brick, and so having those, the adhesion compatibility details of the dissimilar materials, I would think that would be paramount as far as meeting your leakage requirements. What else was I thinking about? Oh, and for the inspectors, do the contractor a favor, not taking a real good look at the continuity of the air barrier during an inspection, or maybe you're doing an electrical rough or you're doing a partial mechanical rough or whatever it may be. If you see penetrations in the air barrier, letting them know that you've identified those, because if it does have to be tested, I mean, we all know that we don't want to have them in there with a smoke gun. And there's actually in the 2021, I believe if you're you can be over 0.4 CFM a square foot, but as long as you're under 0.5, then you can do, I would have to reread that. There's some corrective action you can take that is less rigorous if you just barely fail your air barrier, your blower door test, versus if you fail it badly. What else was I going to ask about? That's really it. I answered a couple of questions as they came in as we went. So I guess that was all that we had. Brian, do you have any parting words before we call it a day?
Yeah, I mean, I think if you go into whole building envelope testing, you should have a failure is not an option mindset, because when you test the whole thing and if it fails, it's very hard to address that.
Yeah, absolutely. And that's, certainly, I mean, LEED would require it. A printout of those questions and answers. I can send, I don't know, that's the first time I've had that asked. Mr. Molina asked for, I can send that to you. Do me a favor, Mr. Molina, shoot me an email and I can send you a copy of the chat. Oh no, because it's for, well, I'll tell you what you can do. If you want the questions and answers, this video will go up on our YouTube channel. Everyone please subscribe so you can rewatch this video at your leisure, fast forward and rewind to where you want. So you'll be able to find those questions and answers there. But I guess that's it. Well, thanks for joining us, everyone, this morning. And Brian, I can't thank you enough. Case studies are always interesting. And I love, as you're going through the slides, thinking, I can't help but put my building official hat on, and I'm thinking about how I'm reviewing the plans for this project, and frankly, how I would have some comments on, you really want to use rock wool here, but more importantly, as far as code compliance, looking at those intersections of the dissimilar materials and look at the continuity of the air barrier. And then when you're out there in the field doing the inspections, I would think most of the time, most of our city inspectors won't really have just a whole ton to do with the air barrier inspections, because I would anticipate that most jurisdictions in Texas are going to turn this over to a third-party inspector, and it would be akin to a special inspection on welds or something similar to that. You're going to have a verified, approved third party go out and do those types of inspections and write reports. was it Carlisle or Alpha? Were y'all on the job once a week, or was it an Alpha rep, or how did y'all QA/QC that exactly? I know you said.
But we have a local rep based in South Texas, and he works a job with somebody from Alpha every week.
Every week, yeah, that's the only way to really do it. And I'm sure, looking, gosh, it would have been so much easier to have sealed those windows prior to the mason. But
yeah.
I guess that's just the way. I don't know.
But that air leakage test requirement made us find a way, right? Because motivated us to do all that work, because at the end of the day, you test the whole thing, it's got to perform.
Right. Makes sense. Okay. Well, folks, we're going to finish about 14 minutes early. So you have 14 minutes of more of your day. It's Friday. Woohoo. That's all we have. Thanks for joining us, everybody. Brian, and I will send a PDF of the slides, and you will get a course evaluation from Kathy. So Brian, if you could just email me that PDF, I will get it out to everyone, and let me know when you're ready for another one. Well done. I can't thank you enough, and thank everybody for joining us. Have a great weekend.
Okay. Goodbye.
Bye, everybody.